Ave Coders, and welcome to the complete tutorial Pandas for beginners, which will help you to gain an in-depth understanding of this wonderful library. This video was inspired by the work of Charles Kelly, so credits to him. But here we immediately begin by declaring a variable Ave data, which can hold an array and p.array, and with another function and p.arrange with argument 24 and reshape. We essentially create an array of 24 elements of shape 6 by 4, so 6 rows and 4 columns. And there at the very top we have imported pandas and made an alias as pd, so now we can call pd.dateRange. Here we can specify the date we want our range to begin with, so it is 1st January of 2021, and we're going to have 6 periods. Down below, we're going to declare another variable, say AveTF for data frame, and we're going to call the data frame function from PD. And we supply our Ave data as the first argument, and as the second argument, we're going to supply the index. So which indices we want to have in our data frame. And we're going to be enumerating our columns with a list of ordinal numbers 1, 2, 3, and 4. Let's have a look what we've got. And as you can see to the left, we have each row preceded by the date, and each column has got 1, 2, 3, 4 as their indices. I should also mention that this library is tremendously popular among those folks working in machine learning or data science because it allows you to do all sorts of stuff. For example, with this simple notation, we can display the column number 4, and it preserved the dates on the left as well. And what we could also do with it is we can perform the so-called slices. So by using the simple notation, we can get the access to the portions of data within our data frame. So we can specify the range of the data we want to get access to. So for example, 1 colon 3, it gives us access to the second and the third row because the first row has got an index 0. So if I'll change it to 4, now we have 3 rows. As simple as that. But we can also get access to these specific records by their indices, which, as you remember, were set up as dates. So the difference is that we're going to specify inside the single quotes, we're going to specify the actual date we're going to start our range from and the date we're going to end our range with. And we should get ourselves 5 records. So indeed, we get ourselves all records that fall within that range from the 1st of January included to the 5th of January included. And we can also use the lock operator. Lock is short for location. That allows us to select subsets of rows and columns based on their index label and column name. Let's say we want to select dates in range 1, 2, 3. So this is what we get. But if I'll change 3 to 5, let's say we're going to do exactly the same expression. Here we've got everything but the very first record because it is of an index 0. We can also use more complex constructions. What if, for example, we want to print out all rows but only the first and the third columns? In order to achieve that, we use colon, then comma, then another square brackets, and inside those square brackets we specify which columns we want to display. In a similar fashion, we can combine our indices, our dates, and we can use the interval we've already used, this one, and we can replace the colon with this interval. And as you can see, instead of all dates, we're going to get the dates within this range, but the columns, first and the third, will remain the same. Here we can modify the interval, and as you can see, it shrinks. We can also involve some arithmetic operations in this schema, so we can use the log. Here we'll take this interval again. We'll start with the 1st of January, and let's say we're going to end here. And inside the square brackets, we're going to say we want the column 1 and 3, and then we want to multiply some value in one of those columns by 5. So value index 1 multiplied by 5 equals 10. So this is essentially the first row and the second element in that row. So the third column, first element is 2. We can also do this trick again and multiply something else. For example, we can multiply the 0 index element. So essentially the first element in the row that begins with the 2nd January of 2021. So as we can see, this is going to be the column 1, and so the element is equal, its value is equal to 4. So as expected, we get 20. All we need just to change the index. And of course the date. If we can perform arithmetic operations, then of course we can look up the elements as well. So we're going to use the variable date that stores all our indices. And if we'll use the index in the square brackets, that will mean the 2nd of January. So this is the second row. And then we specify the column. And here is an interesting thing. So our Ave data is an array 6 by 4, as you can see. It contains all the numbers we populate our data frame with. So we can essentially use indices with this array to access the elements of this array. But we can also achieve the similar result by using ilog, which is a short for index location. So we can use our data frame AveDF, and by using ilog and passing 2 as an index of what we want to get. So we got the pretty much same result, but this time we can see that the index of the record as well as its type, data type, is written below. But we can also pass the which rows and columns do we want to see as intervals. So as you can see here, I have 2 intervals, and here we go. Or we can use commas to separate the values we would like to get. This ilog is quite a flexible function, so we can specify that, for example, we want some rows in this interval, and here we want everything. So here we can see all columns being displayed. So if we use just a column without numbers, that essentially means give me everything. And we can do it the other way around. So we can say give me all rows, and we're going to limit the columns to this range. And here we go, all rows, but only 2 columns within the range specified. And we can also use some conditional logic. So we can say this data frame, give me all elements that are, say, greater or equal to 5. And here we go. All elements that are less or equal to 5 are specified as none, so not a number. You can try different conditionals yourself, but we will move on to our next assignment. So this time we have 40 elements, and the shape of the array is 10 by 4. And we are specifying the start date, which is again 1st of January 2021. We'll have 10 periods starting from that date. And this time our data frame columns will be marked with A, B, C, D, but everything else will stay pretty much the same. So let's print it out, and we shall see pretty much similar array, just a little bit expanded. So we have more elements, more rows, and columns are marked with A, B, C, D. And let's say we want to create a new array, AveDF cars, and we're going to copy all values from the AveDF array. So we're going to use the copy function. And let's say we want to add an extra column to this AveDF cars array. So here in the square brackets, I'm going to specify the column name, so class. And now inside of square brackets again, I'm going to specify the values. I'm going to fill the new column with separated by column. So I'm putting here the first thing that comes into my mind. So we have Ford, Opel, Mazda, Mitsubishi, Renault. So let's say Lada. Then we need 10 elements, so hammer. I'm aware that hammer is spelled differently, but let's imagine this is MC Hammer decided to have his own brand in the world of cars. I don't know, probably electric, and you can't really touch it. So then BMW, Mercedes, and Volkswagen. So that should be 10, and let's print out our new data frame. Here we go. We have all elements from the previous data frame plus an extra column filled with some car brands. By the way, we can access our row indices, our dates, with the function date range, where we supply our start date and then the number of periods. So here we go. And this can help us when working with a so-called series. So series is pretty much a sequence of data stored in an array. It's very helpful if you're going to do some stock prediction, for example. So in here, we're going to create a simple sequence of numbers 1 to 10. And as indices, we're going to use our date range. So we're going to use PD date range with a start date and 10 periods. So this is what we get. And now we can start to do some manipulations with it. For instance, we can add an extra column to our series. To do that, we're going to declare a new variable called Ave series, and I'm just going to copy all that expression into here. And now I can use the values from this series in our DF data frame. So let's say I want an extra column called extra, and it's going to be equal to all values stored in Ave series multiplied by, let's say, 10, and we're going to plus 2 to each one of them. Let's print it out and see what we get. So as you can see, we have an extra column now that consists of values which being in Ave series, but they're multiplied by 10, and 2 was added to them as well. So let's add that extra column to our Ave DF cars. And really all we need to do is just change the name of the variable to DF cars. And here we go. Now we have 6 columns. All right, now what if we want to assign a specific value to a specific element in our data frame? So we can use the function add and construction that looks like this. So we are assigning the Renault value to the element of index 4 in the column named cars, but nothing really changed because it was a Renault before. So I need to pick up some other element from this data frame, or at least change the value. So let's say now it is equal to Citroën. Now the assignment was successful, and we can visually see that the Renault was changed to Citroën. Similarly to lock and ilock, the at operator has also got a cousin, IAT, IAT. In other words, is index at. And we can use this operator to access some specific elements in the data frame, again using the rows and column position. And let's say we want to assign the value of 666. Let's have a look. And as you can see, the element in row of index 3 and the column of index 2 was changed to 666 indeed. Let's change another one. Now I can see there's another row and another column element being changed to this new value. So it is pretty straightforward to use IAT as well. Now let's have a look at some more complex construction. So for example, we have a new array, and we use the array function, and then as an argument we pass the range. So we want to create an array of length of the Ave cars, which is data frame, each element of which will be multiplied by 10, and we're gonna add 5 to the element as well. So here we go. This is an array of 10 elements. As you remember, we have 10 periods, so this will be the length, and each element was multiplied by 10 and 5 was added to it as well. And actually we can take this array and add it as an extra column, another extra column to our Ave cars. So it's going to be named E, and we have Ave new array as a value, and if we'll print it right now, we can see that an extra column was added just to the right of extra column. Now, it's not going to be a huge surprise if I'll tell you that the data in real world is not as clean and as straightforward as it is in the training examples. For instance, we might encounter a lot of missing data in our data sets. And there are many ways to treat that missing data. There are huge debates about how to treat it properly, but we're going to look at some of the tricks that might help us. So I will declare a new array called laptops, and I'm going to fill it in with some laptop brands: Lenovo, Dell, HP, Chromebook, and let's say MacBook as well. And down below I will create a data frame that will consist of some more arrays that will describe, say, price, the hard drive disk space, and so on and so forth. So in order to do that, I'll declare laptops.df, and here I will specify some of the laptop's characteristics. I'll start with the price, of course. And in here I will specify 5 elements, let's say completely randomized price. It doesn't reflect the real market value. I'm not looking it up anywhere. It's just random numbers from my head. So 350, 400, 500, 560, and of course for MacBook is 1000 of some money. The next characteristic is going to be a disk space. Once again, completely random numbers. So let's say 500 of something, I don't know, gigabytes. Always better 0.5 in terabytes, 1 terabyte, 2 terabyte, 3 terabyte, 1 terabyte. Or let's make it float, so 1.5, something like that. And this should be enough for now. Let's print our laptop.df just to glance over our new data frame. So laptops.df. And we should get a really simple data frame that we can later experiment with. Once again, we didn't specify the row indices, that's why it has enumerated them from 0 to 4. But we can actually specify them down below, say index equals laptops. So now we have binded the array of laptops and our indices. So as you can see now, it corresponds to laptops. And let's imagine we decided to create a new array called more laptops. We'll just copy everything we have in the laptops array with a single difference. We'll change Chromebook to Huawei. And let's also create a new data frame. We'll call it a laptops.df 2. And again, here we'll just copy our data frame from laptops.df, and we'll just reindex everything with the help of the function reindex. So we'll pass more laptops in as an argument, and let's print out what we have in laptops df2. And now, as you can see, we have a Huawei in our data frame, but it doesn't have any values. So we haven't assigned any values. That's why we see the none, not a number instead. All right then, so let's create another data frame. We'll call it a laptops df3, and it will be equal to laptops df2. And this time we'll employ the function called drop_na, and we'll pass a parameter how equals any. That will mean that if any na values are present, we'll drop that row or column. And we will show what do we have after removing all nas, or not in numbers. I'm going to print out laptops df3. And as you can see, we have Huawei no more, because, like I said, it just dropped the row that contained the NA values. But if we don't want to lose the whole row, the whole position, because we are getting rid of NAs, we can choose the alternative path, and we can decide to fill NAs. And here in the brackets, we're going to specify with what we're going to fill NAs. In our case, it's going to be value of 100 of something. So now we can see Huawei is back, and all NaN values became 100. We also have a very handy function called isNull that will return a Boolean value for all missing or present values. So let's have a look how does it work. And as you can see now, instead of actual values, we have false where value is present, so it is not null, and true where it is not present, or it is equal to effectively null or nothing. Now let's check out how arithmetic works with data frames. Here, for instance, we can multiply every value by 10, and as you can see, all prices increased, which is not good, of course, but this is just an example. Pandas library also has some powerful inbuilt so-called statistical methods that are very handy and widely used in data science, for example. So one of these methods is called setOption, and here in the brackets we're going to pass the display precision parameter equal to 2. This sets the output display precision in terms of decimal places. If we'll use the describe function with our data frame, we'll see the general statistics. We see number of NA observations, we see the mean of the values, a standard deviation, and so on and so forth. We're also shown the percentiles and values that fall within them. So very handy function. But if we want more verbose information about our data frame, we can use the mean function, which will show us the mean values for price and disk space, as well as values data type, of course. Likewise, if we'll pass an argument to this mean function, for example, we can pass 1, that will effectively mean getting mean values for each row, aka for each laptop. Another great function worth mentioning is function apply, which is effectively a function of functions. I'll show you what I mean. We'll use apply here, and in the brackets as an argument we'll pass the NP cumulative sum, or CumSum, along the 0th axis. So the apply function will essentially apply any other function, almost any, that we can pass as an argument to the values of our elements in the data frame. Let's have a look how concatenation works in Pandas. So just a refresher, the concatenation is basically joining two strings together. So here we declared the variable pieces, and inside the square brackets we're going to pass the range of our data frames elements that we want to concatenate. So in this case we have 3 data frames that will slice, and we'll put all their values within these ranges. We'll put them together. And if I'll now print what the pieces variable contains, it will look ugly, but it's good enough for our practice. So what we're going to do now, we'll declare a new variable called new list. And as you may guess, it will be some sort of a list, which will contain certain elements from pieces that will access via the indices. So in our case, pieces 0 and pieces 2. And now we're going to use the concat function and we'll pass this new list as an argument. And as you can see, we have some sort of a data frame that consists of these two elements from pieces. And as a reminder, pieces was constructed from 3 pieces of laptop DF2 data frame. Here we took an element from the laptop's DF2 by index 2 and we assigned its value to new last row. And now we can take our old laptop's DF2 data frame and append a new last row to it. And as you can see, we have 2 HPs in our data frame. All right, that is all jolly good. So let's move on and have a look at another important function called merge. So merge allows us to, surprise, surprise, merge data frame or named series objects, but with a database style join. So in this case, we have 2 data frames left and right, and our variable result will contain the result of the merge of this left and right data frame on the key called myKey. So here we have a joint table where left and right were merged by myKey. However, if you're not really grasping how it works, I would recommend the SQL with PostgreSQL playlist on my channel, where this mechanism is explained very well. Now let's talk about the data import. Sooner or later the time will come to import the data, and there are plenty of resources, but most I would say famous one is the Kaggle, where you also have some competitions, and the UCI machine learning repository, which we're going to use in this tutorial. Here you can find good amount of well categorized data sets, and this resource can be a safe harbor for when Kaggle doesn't work for one reason or another. So let's import some bank data. I'll create a variable called bankdf, and I'll use the function readCSV because it's going to be a comma separated value. So in essence, the repository where data will be separated with commas, and you can grab the file in repository, my repository called Ave Coders. I'll leave a link in the description under the video. Please check it out. Here we'll specify the path to the file. And in case you're getting an error, the file does not exist, please check the path, especially slashes. And let's print the first 100 rows of the file by using the function head and passing 100 as an argument. And as you can see, this is how our file will look like. So it doesn't look particularly pretty. And as you can see in this example, values might not always be separated by comma. In this case, this is a semicolon. But I brought up this example just to show you how we can read the CSV file, and also likewise how we can write the CSV file. So in order to do that, as you might guess, there is a function available in Pandas, but this time it is called toCSV. And again, here we have to provide a path. Let's imagine for this example that we have modified this bank CSV. Nevertheless, we didn't do that, but still, let's imagine we did this. And we can rename our file into bankupdated.csv. So it will essentially create a new CSV file, and it will copy the content of our data frame to this file. For the next portion of exercises, we'll download another file. This time it is an Excel file, just to practice on different formats. So in our case, this is online retail, which I took from UCI. So I'll leave the again the link to my GitHub with this file in the description, but here, just in case, you can see where I took it from. So essentially go to UCI Machine Learning Repository, you click on Data folder, and here you can see the data. Anyway, we'll need to create a new data frame for this file, and I'll call it Online Retail. Let's say df. And this time I'm going to use the function read Excel, and as an argument I'll pass the retail file, which is essentially the variable that keeps the path to the file. Second argument would be either the name of the file or the name of the tab. So if we have several tabs in our Excel file, we can specify from which tab we want the data to be imported. So the value of the next parameter specifies that we don't want any indices on columns. And the next parameter specifies how we will deal with NA values. So in this case, we're going to be just marking them as NA. After we have finished with all necessary preparations, let's have a look how our dataset actually looks like. But this time, instead of using the head function, I will just print everything. But the default behavior will be that it will print actually 5 first rows and 5 last rows of the file. So this essentially will be the data set that we will modify. So let's have a look first of all on the sort of SQL equivalent function group by, which allows us to, surprise, surprise, group the elements by a certain index. In this case, we want quantity, but we want the sum of the quantity as well. And as you can see, here is the sums of the quantities we have in our dataset. Again, first 5 rows and last 5 rows. And again, this is quite useful that Pandas displays a small statistics at the bottom. So let's do another group by, this time by country. So I'm going to put country inside the quotes, but this time we're going to be counting, not summing. So in other words, we just counted some values inside some group. Like here we can see we have 1,259 invoices for Australia, 1,086 for Norway, and so on and so forth. You've got the idea. So let's move on, and this time we'll talk about the resampling. I'll show you in a second what it is and what it does, but first let's declare a new variable called Ave index. And Ave index will hold some kind of a date range or date interval. Here as the arguments, we're going to pass 1st of the January of 2021, and we're going to stretch it for 10 periods, but this time one period will mean a minute. So essentially 10 minutes from the 1st of January of 2021. This is pretty useless, but just for the sake of the experiment, let's do so. However, if you had some kind of a New Year resolution to do 10 things after the 1st of January, this is quite a useful example. But here you can see that we've got essentially 10 minutes from the start of the year. And let's say we want to declare another variable which will be called Ave series, and it's going to contain a series. So 10 consequent events or values, and they're going to have indices Ave index. So as you can see, those time periods are now playing the role of indices, which is pretty cool if we want to restore some sequence of events that happened within a certain time range. So this is essentially what is known as the timestamp. How we can utilize this? Well, let's imagine we have Ave series and we decided to split it into like a 5-minute interval. So we can use the resample function and we'll sum all the numbers that fall within those time periods. And if, say, we want to analyze the sales and those numbers resemble the number of sales within the time period, we can see that the first time period was poor in sales or poorer than the second one. We can also change the way the interval is labeled. By default, it is labeled from left to right. So if it starts at 0, 0 and ends at 5, it will be marked 0, 0. But if we'll change the label to right, it will now start with 5. So that was the ending label. And the next interval will begin at 10, which was the ending time for the second interval. We can also specify another parameter, closed, which is left by default as well to right, which will basically specify that the interval now closes after 5, not before 5, and that will mean that extra numbers, extra values are now included in the interval. So before that, the interval was closing on the left, so we've been counting all numbers, all values up to the 5th minute. So now we change it to the right. We're counting everything up to the 6th minute, so the end of the 5th minute interval. We can also upsample our series into 30-second bins. And let's say we want to have 5 intervals, so 5 bins. I'm using the function asFreq for as frequent. And as you can see, some of them store the none value, not a number. That is essentially because the intervals are too narrow to hold any original value. We can also create our custom functions and pass them as an argument to the resample function. So here, for example, we want to perform some custom arithmetic operation. So this function takes as an input the array-like object, so any sequence that can be interpreted as ND array, that includes nested lists, tuples, scalars, and existing arrays. And it performs some operation and it returns the value of that variable temp. So now we can use it in our resample function, but we can't pass it straight as an argument. We have to use a helper function apply. So let's instantiate a new variable called Ave series and resample. Here I give the interval in 3 minutes, and here I'm using the function apply, and inside the apply I'm passing the custom math as an argument. So essentially now the values are within the 3-minute intervals being affected by the mechanics of this custom math function, which we created ourselves. And this is quite handy mechanics overall, especially when you need to perform some complex computations. By the way, there is another way to create and populate a series in Pandas. So here we declared the variable our simple series, and we're going to use the NumPy random function. So essentially we want 5 elements in that series, and we can also specify indices. So in here I will separate some indices with comma inside the square brackets. So this will be A, B, C, D, E. And essentially it creates a series with the specified indices but random values. And because series in essence is a one-dimensional ND array just with access labels, we can access the elements of the series by their indices. So for example, here I'm creating a variable Ave simple series, and in here I'm creating again another array with 5 random values, this time without custom indices. So I will be allocated automatically some sequence of numbers that will serve as indices, and now I can use the index of a certain element or a certain record, a certain value, or even perform a slice. So I want everything up to the index 3. And again, it's kind of cute that we've been given a data type as well. Now then, let's have a look how dictionaries work in Pandas. So here I'm going to create a variable Ave Dictionary, and I'm going to specify several key value pairs. So these values are totally random. They come out of the random number generator in my head. And let's say we have 3 key value pairs. So here is our dictionary. So let's create a new variable now, another series, which will hold the series, and here as an argument we'll pass our dictionary to it. And of course, let's have a look how does it look like. In essence, what you might observe is that the keys became indices and values remained, well, values. And because keys essentially became indices, we can now access some values by using their keys. If we'll supply 2 arguments into our pd.series, let's say we'll pass our Ave dictionary, but this time we'll add indices ourselves. So let's say pd.series Ave dictionary, and then comma, and here I'll specify the indices. And I'll specify them in absolutely random order. Say DCB, something that didn't exist before. So we don't have the corresponding keys in our dictionaries for these indices. And as you can see, those indices not represented in our dictionary as keys will return none. We can also use the get function to retrieve a specific value, and we're going to use the index or the key. So let's say A returns 30. And of course, we can also change the default behavior when we try to retrieve something that doesn't have a value. It returns none, so we can also change that. But another example, of course, it is the creation of a series from a scalar value. So essentially, we can create a whole series from a single value. Let's say in our case, it will be 5, and here I can copy and paste these indices. So we have 5 indices, and as you might have guessed, we're going to get a series of 5 elements, each of which will be equal to 5. Let's see how the simple arithmetic operations work with the series. So for this example, I'll take Ave simple series and I will add to it Ave simple series. So as you can see here, we get the result. Every element was summed up with the corresponding element in the second series. That being said, not only we can use the arithmetic operations between series, but we can also do arithmetic operations on series and say scalar values. So in this case, I'll take Ave simple series and I'll add 1,000 to it. So every element in that series was increased by 1,000. Similar goes with the multiplication. Say here we multiply every element by 5. And we can also supply the series as an argument to the NumPy function, say exponent. So you've got the idea. So series is quite flexible, and as being in essence an array, we can also perform, say, slices. So say in this case I want to print all elements starting from the index 1, and here we go, we have 4 elements starting from the index 1. But in case we want to print everything but the last element, we can use the -1 index. So in this case, I'm saying something like, give me everything but the last element. But interestingly enough, if we'll try to sum up those modified series, so the one that doesn't have the first element and the other one that doesn't have the last element, then we'll discover that only those elements present in both series been summed. Those that don't return a none. Despite of these elements being present in one or the other series. So logically it could have just left them as they are, but here we go. For the next trick we're gonna need a function, we'll call it mult by 10. It's gonna take some input, so let's say an input element, and it will return this element multiplied by 10. So essentially what we're going to do, we're going to apply this function to a certain element. We've already seen pretty similar mechanics with the apply function, but this time we're going to use another function called map. So essentially it is used for substituting each value in a series with another value that might be derived from a function. In our case, this is a mult by 10 function. So I'm going to use the Ave simple series, then this map function, and as an argument, I'll pass mult by 10 function. And we got the result. Every element was multiplied by 10. All right, let's move on. Imagine that we have created another series, so a series of random stuff. So all those elements are pseudo-random in terms of meaning. I've just created them from my head. Let's print them out. Let's see what we've got, how it looks like. But this time I'm going to use the function str and I'll put them all into lowercase. So essentially str is a vectorized string function for series and index. It allows us to do some stuff with string values. So for example, in this case, we're putting them all in lowercase, but we can also split them and replace them. But let's move on to the date arithmetic. So let's have a look how we can work with the date and time in Pandas. First, of course, we'll have to import the date and time from the date and time. So now we can use built-in date and time functions for our tricks. For example, we can print the current date and current time by using the now function. As you can see, this is the time I was recording this video. But we can also specify the exact date and time features that we want. For example, we can use now year, now month, and now day. So we essentially cut off the unnecessary information. But that's not all. We can also use simple arithmetic to display how much time have passed since a certain date. Let's say we here declare the variable delta, and we'll deduct a certain date and time from this now variable, which essentially reflects the date and time when this video was recorded. So this delta will be measured in days, then seconds and microseconds. But essentially we're only interested in days. Therefore we can use the delta.days to display just the difference in how many days passed since now and that specific date. We can also pass a string of a certain format in the date format. So we're going to use the time delta function for it, and we're going to pass the string, which will specify the date we want to pass. So in our case it's 5 days and 10 hours. Magic. But we can also specify it in a slightly different format. If we'll use the same time delta, but this time we'll say something like days will be equal to 2 and seconds will be equal to, let's say, 10, then we'll get 2 days and 10 seconds in this format. Another way to specify a certain time period is to supply the unit and the number of units. So in this case, D stands for days. So we have 1 day and 0 seconds. But let's have a look at more complex example. So in here, I've specified the date and time for the New Year, then date and time for National Absurdity Day, and date and time for Tuvalu Independence Day. And say I'm deciding what is the best time to take my annual leave. And I know that the quietest time of the year is between National Absurdity Day and Tuvalu Independence Day. and I'm going to print how much time do I have to relax. So essentially I've got 50 days to relax, which is nice. But let's say we want to create a time series out of these construction. So I'm going to use time to relax a range variable, and it will be equal to pd.dateRange. And here are my arguments. So the first argument is when we want our time series to start. So it's going to be National Absurdity Day. After that, I'll specify the number of periods. But this time I'm not going to use the scalar value. I'm going to use the value stored in the time to relax variable. And I want it in days. And then the frequency, which is going to be days. The next step, I'm creating a time to relax series, and I'm going to use pd.series. And here I'm going to use the random or pseudo-random number generator to generate some values. For this example, it is not so important to make them to represent something meaningful. So I'm going to just pass time to relax.days, and I'm going to use the time to relax range for the indices. Now let's print it out and see what we come up with. But I'll print out the tail, so the last 5 values in this series. So as you can see, this time series was populated with some random numbers, and down below we can see that it specifies the frequency in days and the data type as well. And now let's get back to the data frames and have a look at some more of the key or important functions we can use with them. So here we created a dictionary, and we want to print the dictionary keys, so ABC, and the dictionary values. Let's print them out, and as we can see, we got pretty much the expected result. Keys and values are printed separately. Now let's create a data frame. We'll call it Ave Dictionary DF, and we're going to use the data frame function, and as arguments we'll pass the Ave dictionary, the first one which we have now created, and as indices we're going to pass 2 words, start and finish. So essentially keys in Ave dictionary will become indices, the values will remain values, and let's print it out. So essentially what we're going to see is that the values of that dictionary will become values for the row that is start and the row that is finish. So essentially it created duplicates to populate the data frame. All right, let me show you some more examples. I've already prepared them. I'm going to explain what's going on. So the first construction is another data frame that holds a dictionary that consists of a set of keys. So we have one key and several values corresponding to that key. So essentially those values will be spread by the rows. In the next example, we have a dictionary. The keys are represented with strings and values are represented with series. And the value that doesn't exist returns as none. And here's a bit of a homework for you. So we have a fresh stuff that is a dictionary. It consists of vegetables and fruits. There are the keys, and the values are lists. So you can create a data frame corresponding to the fresh stuff. And the last example is the data frame that holds the list of dictionaries, and this is the representation. And as you can see, the first dictionary is 1 value short, that is returned as none. Alright, so that was literally Pandas in 1 hour. I hope you enjoyed it. Please give this video Emperor's thumbs up, toll the bell, and subscribe to the channel if you're not subscribed yet. And I'll see you in the next lesson. That was V. Thank you and goodbye.